We are here for today's class work. That and in our classwork, we design a solar system. We solve questions. Now, question for today, for our class work 2. It now say, connect a solar panel circuit with 10 pieces of 460 watts. Connect a solar panel circuit. Connect a solar panel circuit with 460 watts. Connect a solar panel circuit with 460 watts solar panels with the output to feed 48 volts. With the output to feed 48 volts DC. 48 volts DC using PWM solar charge controller. Using PWM solar charge controller. This is the question for today. Connect a solar panel circuit with 10 pieces of 460 watts solar panel with the output to feed 48 volts DC using a PWM solar charge controller. So, solution. We must bring in the electrical parameters under standard temperature condition of 460 watts panel. Now, and that is what we want to look at now. We want to look at it now. When the maximum power of it is maximum power, P maximum, is equals to what? 460 watts. The open circuit voltage is 39.7. 39.7 volts to what? 42.6 volts. That is the open circuit voltage. So before we continue, we need to put this into consideration, the open circuit voltage of the cell under standard temperature condition. Then the maximum power voltage this is the maximum power voltage that it will generate. Short circuit current is 13.5 to 14.6. 13.5 to 14.6. After the short circuit current, we are now looking at the maximum power current is what? 12.8 to what? 13.9. 12.8 amps to 13.9 9 amps. You talk of the power tolerance, positive or negative watts, 5 watts. That is commonly. That is what we use. But then we are not looking at that at this moment. We have gotten the key point that we needed in this calculation. Now, having gotten that, we need to quickly go and take the drawing. Remember, don't forget that our target is to have 48 volts DC output from this panel to feed the PWM solar charge controller. Now, if we are doing that, don't forget that the open circuit voltage here is what? Is what? 39 volts. The open circuit here is 39 volts. This 39 is not up to 48. Therefore, we have to do what? Connect two panels in series to get the 48. Yes, as you can see, we connected these two panels now in series. Connect these two in series, connect these two in series. Now, if each of them give us 39 volts, that means 39 times 2 is giving you what? That is 39 times 2. It gives you 78 volts. So this 78 volts can actually power the PWM of that 48 volts. So we are left, we are still having 4 panels under. So with this 4 panel here, we'll now take this particular let me follow it in this way so that it will be clear. So here we have this, connected these two in series, connect these two in series, then connect these four now together in parallel. So if you connect it in parallel, this parallel now connected to this parallel, we have this live. This positive now will go straight to this positive, and this negative will go straight to this negative. So at the end of the day, you have how many? 48 volts system here. I'll be giving to you. This is a block diagram of solar panel connection series to parallel. So this answer A. This is the answer to the first question A, the block diagram of the system. Now B. Want to look at question number B. What is the total output current of the circuit? And that is why I say the parameter is very, very important. The maximum power current of this particular solar panel is 12.8. That is why we are taking 13 so that we can get it. Now, we look at it very well. I am cleaning this now. Now, we now want to calculate the total amps that will be the output amps of this solar panel that we connected in parallel. So, we have, that is the individual amps. We are using 13 amps at the mean. That is power current, maximum power current is equal to what? 13 amps per panel. From our electrical parameters of the panel, that is where we got this 13 amps from. If you want to check it, it's on a small paper at the back of the panel. You will see it there. Now, as you have gotten this 13 amps, remember that is 10, and that 10, two are connected in series. When a solar panel is connected in series, the amps remains the same. But when they are connected in parallel, the amps increase. So now we are now looking at these 30 amps. 2 that are connected in series is 2 plus 2 plus 2 plus 2 plus 2. That gives us that 10. And each one is giving you 13 amps. So we have 13 plus 13 plus 13 plus 13 plus 13 is equal to 65. This one is a total panel. And this one is the output current. So as simple as it is, if you make a mistake, it can generate to a big problem, and that is why it's good you know it very well. So now we are looking at when it is connected to 24 volt system, PWM 24 volts. That's what we are looking at now. Now, since using 24 volts DC system, (24 volts) can take in up to that 39 volts. So what we need to do, watch out as we draw the diagram now. The 10 panels will be connected to this 24, and it is no longer 38, it's 24, 48. It's 24 volts that we are using now. Watch. This is where a lot of people make mistake. So since the 24 volt can accommodate up to that 39 volts, we'll take it straight. Yes, as you can see, it's connected in parallel. Easy how it will be connected. Now we have to calculate the amps for the charge controller. This is out of range, but for the sake of class, we have to do it so that people know how to navigate when they are faced with different challenges in the site. So the parallel connections, when we talk about the parallel connection, when the panel is connected in parallel, the amps increases, then the voltage remains the same. And as such, what you need to do, the output current is equal to what? 13 amps times 10. is equals to 130 amps. So the output current is 130 amps. Thank you for attending this class. Don't forget that subsequent time we'll discuss other ones. Subscribe to this channel for you to gain more.